In this course, I will talk about a comprehensive list of all the operators in C with detailed examples. Namely, they are arithmetic operators, relational operators, logical operators, bitwise operators, and many operators. Just display it as here. Now, let's start to see the operators in C. Just prior to the start on the operators, we need to recall two keywords, namely bit and byte. Because here we are going to talk about bitwise operators. This bitwise operators is very important in C because if we properly use bitwise operators and logical operators, we can improve the speed of the code execution. Why we use C now? Because we are going to use C in system programming and embedded systems most of the time. These kinds of programming operations need performance. Therefore, we are going to learn C here. In order to use the bitwise operators effectively, we need to understand what is a bit, what is a byte, and what is their relationship. Okay, let's see that. First, let me explain the bit, and then I will explain the byte. Okay, let's talk about bit. Actually, a bit is the smallest unit of data in computer. Bit representing a binary value of either 0 or 1. In other words, think of a bit as a small box that can either be empty or filled with 1. Namely, let's assume that this is a bit and this is corresponding to a box. In this box, we only have two options. One is this box is empty. The second option is this box filled with 1. Or in electrical stats, for example, let's assume this is a switch. At that time, we have only two options. One is off and the second option is on. In the case of off status, there is no current flows. In the case of on status, there is current flows. Therefore, bit is two options, 1 or 0, on or off. Okay, now we have understand the bit. Okay, if so, what is a byte? A byte actually consisted of 8 bits. Namely, we just saw that bit, a box, and there are 8 boxes. Namely, the first one, this is the 8th one. Namely, the combination of the 8 bits create a byte. In other words, a byte or 1 byte consists of 8 bits. 1 bit, second bit, and this is the 8th bit. Therefore, a byte is a combination of 8 bits, or a byte is, in other words, for example, this is just example. In electrical status, for example, a combination of 8 switches. Okay, therefore, we just saw that in a bit, we have only two options, off or on, 0 or 1. Therefore, the byte, we just saw that the definitions of byte is 1 byte consists of 8 bits. Therefore, 8 bits will provide 256 options. Therefore, we can represent 256 different values with a byte, namely from 0 to 255. This is the relationship between the bit and the byte. Now, let's talk about the operations in C, because in the coming sections we are going to talk about bitwise operators. Therefore, we just talked about the bit and the byte, because at that time we use this bit and the byte concepts. Okay, now let's talk about the first operators. Namely, we are going to talk about the arithmetic operators. Actually, these operators perform basic arithmetic operations in C. Namely, plus, this represents addition, minus represents subtraction, star represents multiplication, slash represents division, and the percentage represents modulus or remainder of division. These are the basic arithmetic operations in C. Now, let's see an example for arithmetic operations. Okay, now let me clear all of this because last time we just used this code. Okay, I will clear this as well. Now, actually, I have prepared some code for arithmetic operators. In order to save time, I just copy and paste it here. So let's see here. First, we have two variables. Last time we learned about variables and values. And the data type is int. We assign 10 to A, 3 to B. This is the addition, and this is the subtraction, multiplication, and division, and the modulus. These are the arithmetic operations. Let's run the code and see the result. Hopefully, these results will be get. Okay, now let's run this. This is the result. Addition equal to 13, subtraction 7, multiplication 30, and 3 and 1. Therefore, this is very simple, and this is the printf of the result. Okay, this is the arithmetic operators in C. It's very simple. Okay, now let's see the second operators. Relational operators are used to compare two values. For example, if we have a two value 1 and value 2, and then we need to compare these two values. Based on this comparison, namely the result of comparison, we are going to do something or we are not going to do something. Basically, in the condition, we are going to compare two or more values. They return either one. For example, we have a condition here, and then we compare value 1 and value 2. In this case, they return either true or false. For example, if this value 1 and the value 2 is same as that time, this will return us for 1. And we explain it yes. Then, if these values are not same or not equal at that time, this condition returns us 0, meaning no. Therefore, when you use this kind of condition, we just use these relational operators or comparison operators. These are the operators compare two values and return a Boolean result, meaning 0 or 1, false or true. Okay, the first one is equal. This is equal operator. If A equal to B, then not equal. A not equal to B, then greater than. For example, A greater than B, or A larger than B. And this operator is less than. For example, A less than B. And this is a greater than or equal. Greater than or equal. For example, we just use just like this. And then the final one is less, because this is the less and this is the equal, less than or equal. We use just like this. Therefore, these are the operators that compare two values and return a Boolean result. Now, let's see an example. Clear this one. And I have prepared same example for the comparison operators. First, let's see the equal operator. A's value is 10, B's value is 20, therefore A equal to B returns false because this is not true. Therefore, this combination or this relationship, this operator will return 0, false. Then A not equal to B. This is true actually because A is 10 and B is 20. And therefore A not equal to B. This is true. Therefore this operator will return 1, namely true. Here the third one is A greater than B. Actually A is 10, we know that, B is 20. This is not true. Therefore this relationship, this operator here returns 0 or false. Then finally A is less than B. Actually this is true. Therefore it returns 1. This relational operators or comparison operators is very important in the common sections in any language. Therefore we just show this example. Okay, now let's run this and see the result. Okay, because A equal to B, this is not true. Therefore this value is 0, returns 0, and A not equal to B, this is true actually. Therefore it returns 1 or true. Therefore this is the result. Logical operators allow us combine multiple conditions or reverse the logic of condition. For example, these are the logical operators in C. The first one is AND. The second one is OR. The third one is NOT. Now let's explain this. First, logical AND. We have two variables here. The one is A, the second one is B. Actually, A and B. Meaning is A and B both are true. Only this red portion is in the meantime belong to A and also belong to B. Therefore, the logical operator AND, namely A and B, just represents the red area, which belong to A, also belong to B in the meantime. Okay, in the case of O, A or B, meaning is either A is okay or either you select B is okay, because whole A is red now, the whole B is red now. Therefore, either we take A or either we take B is okay. Either one is okay. Therefore, A or B. Meaning A also okay, B also okay. Finally, the logical NOT. This operator, for example, not A. Meaning is actually this portion is A. Not A, meaning is this red area. This area not belong to A. Therefore, it's not A. Therefore, in the case of logical NOT, it represents the red area. Okay, now let's see example. Okay, I just clear this and paste the example for logical operators. Now let's see this code. Okay, first we have two variables A and B. Their value is 10 and 20. The first one is logical operator AND. We just saw that logical operator AND require both conditions are true. Meaning A equals 10, B equals 20. This is true actually. Let's see here, A is 10 and B is 20. Therefore, the first condition is true and second condition is true. In the case of both conditions are true, at that time, this will return 1 or true. Actually, this is true and this is true. Therefore, this operator returns 1 or true. Now, let's see the second operator OR. In the case of OR operator, this requires only one of the operator is true. Both might be true. Okay, let's see here. A is 10, this is true. Here B is 20 actually, but here B equal to 30. This is not true, but this is true. Therefore, it's return 1. Either one is true. This one true or might be this one true. Either one of the true at that time, it returns 1. If both are not true at that time, this operator will return 0 or false. Now, in this case, one of the condition is true, therefore, it returning is 1. This is correct. Now, let's see the NOT operator. Actually, NOT operator meaning is the reverse. It's reverse the condition. Actually, let's say here, A is equal to 10. Namely, we assign 10 to A. Therefore, the value of A is 10. Let's say here, A equal to 10. Actually, this is true. But here, in front of this, outside the scope, we have NOT. Therefore, it's returns 0. This is NOT operator. Okay, now let's run this and see the result. Okay, hopefully 1, 1, 0. Okay. Here, this is the first one, 1, 1, 0. Okay, now let's see bitwise operator. There are several types of bitwise operators, including bitwise AND, bitwise OR, bitwise XOR, or bitwise exclusive OR, bitwise NOT, left shift, right shift. All of these work on bits and perform bit level operations. Namely, if we have a two variable here, for example A and B, we just assign it 5 to A and then assign it 9 to B. Then this is the binary representation for 5 and this is the binary representation for 9. Now, let's see the first one, namely bitwise AND. What is bitwise AND? Actually, in the case of bitwise AND, we just compare each bit of two numbers and returns 1 only if both bits are 1. Okay, meaning we have two numbers here and this is the binary representation of the two numbers and we just compare corresponding bits. When we compare it, only in the case of both bits are 1, we just return 1, otherwise we return 0. That's the rule. Okay, I repeat again. Compare these two numbers in terms of bits and returns 1 only if both bits are 1. Otherwise, we are going to return 0. Okay, let's see it. We are comparing this bit is 1, first bit, this is the 1, therefore we just return 1, and this bit is 0, this bit is 0, because they are not 1, therefore we just return 0, and in the case of this bit, this is 1 and this is 0, therefore they are not both 1, therefore we just return 0. This is also same. Therefore, when we take bitwise AND between this A and B, the result is 1. Namely, A and B in terms of bitwise operations, the result is 1. This is the result. Actually, this is the binary representation of 1. Okay, now let's see the second, namely, let's see the bitwise OR. If we have a two condition, the first condition is true, the second condition is false, at that time it's okay, true, because one of them, either one is true, it's okay. Therefore, bitwise O compares these two numbers in terms of their bits and returns 1. At least one bit is 1. We are comparing two bits, for example, this bit and this bit, or this bit and this bit. Therefore, return 1. At least one bit is 1 among the two bits we are just comparing. Okay, let's see. In the case of this bit is 1, this bit is 1, because at least one bit is 1. Okay, both bits are 1. Of course, we return 1. In the case of this 0, 0, this is return 0. In the case of this, we are comparing these two bits, and at least one bit is 1, because this bit is 1, therefore 1. In the case of this is 0, this is 1, because this is belong to the at least one bit is 1, therefore this is 1. Okay, therefore A or B, and the result is 13, because this is the binary representation of 13, or this is the binary result of the comparing two variable A and B. Okay, now let's see bitwise XOR or bitwise exclusive OR. In the case of bitwise exclusive OR, we are going to compare each bit of two numbers. We have each bit of two numbers and returns 1 if the bits are different. Only bits are different, we just return 1. This bit and this bit are different, therefore we are returning 1. This bit and this bit are different, we are just returning 1. This bit is of course 0. In the case of 0, we just return 0. But this bit and this bit are same, and they are 1. This time we just return 0, because this is exclusive. A exclusive or B. The result is 12. Because where this result comes from? Because this result comes from the bitwise operations between the 5 and 9, namely exclusive or between 5 and 9 is equal to 12. Okay, now let's see the bitwise NOT. In the case of bitwise NOT, we just flip all the bits of the number. For example, if we have a number 5 here, this is the binary representation of 5. Now, in the case of bitwise NOT, we just flip it. For example, flip means we know that because this is a bit and this bit, only two options, 1 or 0. When this bit is showing 1, we flip it, it of course shows 0. Therefore this is 0. And then this is showing 0, and when we flip it, it should be show 1. And this is 1. When we flip it, it will be 0, and this is 0. When we flip it, it will become 1. Just flip it. Okay, just like a coin. It's front and back. The 1 is front and the 0 is back. Therefore, we just flip it. And then this is 5. When we do the bitwise NOT, it will become -6. Why? Because I am declaring this 5 in data type. Actually, we know that int data type occupies 4 bytes of memory. Therefore, actually, this 5 is int. Therefore, actually, we have 32 bits here. This is the first, second bit, third bit, fourth bit, and we have fifth, the sixth, and the seventh, ninth, and until here 32 bits here. Then, because this is 5, only I just show in terms of space, I just shows only the first 4 bits of 5. Then I just flip it. Actually, there are 28 bits here, but the 28 bits is all 0. When we flip it, of course, they will become 1, because we are just flipping it. And actually, they are representing the sign. Now, let's see the left shift. Left shift means is shift the bits of a number to the left by the specified number of positions. Zeros are shifted into the rightmost position. I just prepared the definition and let me paste it here. Okay, actually left shift means is shift the bits of a number to the left by the specified number of positions. Zeros are shifted into the rightmost position. Okay, this is the left shift. For example, this is the number we are going to shift one position to the left. Namely, shift the bits of a number. This is the bits of a number 5 to the left by the specified number of positions. This is one position, specified number, one position. Zeros are shifted into the rightmost position. Zeros are, at the result, zeros are filled with the rightmost position. This is the rightmost position. Now, let's shift it, because we are going to shift this one to the left, one position to the left. For example, in the result, this will be, now this is the first bit, and this first bit will become the second bit, because we are going to shift it to the left, and then this will become here, this will become here. But the rightmost position, because we just shift it, this is the first bit, and there is 0, therefore this position fill it with 0. This is the meaning, or this is the rule for left shift. Then this is the result of the left shift of 5. Okay, 5 and 10. Let's see here, left shift one position actually corresponding to multiply by 2. Okay, we have a number, or we have a variable 5, then we multiply it by 2, it's equal to 10. Namely, left shift the number is equal to multiplied that number by 2. Okay, double that number. Okay, that's it. Then let's see the right shift. Actually, the rule is same, but direction is different. Okay, the first one is shift to the left, the second one is shift to the right. For example, we have this variable b and its value is 9. Now let's see the b shift one position. Okay, shift the bits of a number to the right by the specified number of position. For example, one position. At this time, the leftmost position are filled with the sign bit. Okay, let's do it. Okay, we just shift this left. Okay, because in the left there is no position, and this is gone. Okay, this is come to the first position, and this is come to the second position, and the fourth position comes to the third position, and then the most left position, this position, fill it with 0, and this is the result. Therefore, we just seen that bitwise operators. Bitwise operators is very important. If we properly use bitwise operations, we can speed up the execution speed of a code. We just saw that here, left shift one position is actually equal to multiply by 2. Namely, in computer, the multiplication and the division is very expensive. If we properly use this kind of bitwise operations, at that time we can speed up the execution of a code. Therefore, bitwise operators is very important. Actually, I have added some helpful information to this figure, namely this bitwise operators figure, in order to make it easy to understand them, especially to the left shift and right shift portion of this figure. I also added some information to the bitwise note portion as well. Namely, added some arrows to the left shift portion, and also added some arrows to the right shift portion as well. Namely, these arrows help us to understand where this bit will be moved. or where this bit will be shifted. Therefore, this information make it easy to understand. And then also added this information because in the case of left shifted, this position should be filled with 0. Therefore, I just added this information for this position. And then in the case of right shifted, this position actually should be filled with 0. Therefore, added this information. Then in the case of bitwise node, this process is actually flips all bits. Therefore, just added this information. Let's see example. I just prepared the example. First, I copy it and paste it here. First, clear here, then paste it here. Okay, this is the example. Actually, we just see these examples in here. Actually, we have A and we have B and 5 assigned to A, 9 assigned to B. Okay, let's see in detail. First is bitwise AND, bitwise OR, bitwise exclusive OR, bitwise NOT, left shift one position, right shift one position. And these are the results. We just saw that in the previous section in the explanation. Okay, now let's run this code and just display this in the standard output. Hopefully these kinds of results will be displayed. Okay, now let's run the code and this is the result. Okay, let's see that the 1, 1, 13, 12, minus 6, 10 and 4. Okay, this is the results. Okay, therefore, in this section, we just learned about the bitwise operators. Bitwise operators are very important. If we properly use bitwise operators, we can improve the speed of code. There are several assignment operators. Assignment, add and assign, subtract and assign. This is subtract and assign. Then multiply and assign, multiply and assign, divide and assign, divide, division and assign, and the modulus and assign, modulus and assign. Therefore, these are the assignment operators and the use to assign values to variables. We know that when we declare variable, we always assign some kind of value. For example, in the previous section, we declare two variables A and B. For A, we just assign it 5. For B, in the previous section, we assign it 9. Okay, therefore, this is the assignment operator. And this is the add and assign. Actually, this is equal to just like this. First, A plus B, namely A add B, then the result will be assigned to A. Okay, let's see in the example in details. I just delete this and just paste it here. This is the example. We have a variable here A and this is the assignment operator. We just assign it 10 to this A. This is the first assignment operator. Actually, this is the add and the assign operator behind the scene. This is the process working. Namely, first we have the variable A, then add 5, then the result will be assigned to the A again. Therefore, this process simplified just like this. Let's see this one. This one is subtract and assign. Actually, behind the scene, this is the process. Namely, first we have A, then minus 5, and this process can be represented by using this kind of simplified operation. The next one is multiply and assign. Namely, we have A here, then first we multiply it by 2, then the result will be assigned to A. This is the simplified version, and this is the another version, namely this is the actual version. Okay, then we have divide and assign operator. The first variable a divided by 2, then result will be assigned to a again. This is same as the above, just the simplified version of this whole process. Namely, first we have a, then we are finding the modulus of a by 3. The result, of course, is 1. Then this one will be assigned to a again. Therefore, these are the examples for assignment operators. Now, let's run the code and see the result. Hopefully, we will get this kind of results. Namely, 15, 10, 20, 10, and 1. Okay, let's see that. Okay, this is result 15, 10, 20, and 10, finally 1. Because at first we have 10, then we added 5, 15, then now we have minus 5, we have 10, then we multiply it by 2, 20, and at first we divide it in 2, 10. Finally, we find the modulus of 10 by 3, therefore we just get 1. These are the main assignment operators. We always use this, and actually these assignment operators simplify this kind of detailed processes. Okay, now let's see other operators. Increment and decrement operators. Plus plus, we call it increment operator. Minus minus, we call it decrement operator. Actually, these operators increase or decrease the value of a variable by 1. For example, if we have a variable x or if we have a variable a, when we apply increment operator, its value will be increased by 1. If we apply the decrement operator, its value will be decreased by 1. Okay, that's the main idea, or that's the function of these increment and decrement operators. Now, let's see one by one. First, let's see the increment operator. Actually, there are two types of increment operator. The first one, post increment. Namely, if we have a variable a, then we are going to implement, or we are going to put this increment operator after the variable. In this case, we call it post increment. Then, if we have a variable a, and we place the increment just front of the a, we call it pre-increment. Actually, these two types of increment has some difference. Let's see the difference in example. Okay, now let's declare two variables, x and a. Actually, we are assigning 1 to the a. Okay, in this case, we just applying this increment operator to a and assigning it to x. Actually, now we have two operators here. One is assignment and the second one is increment operator. Therefore, in this case, first this a assigned to x, then the a's value will be increased by 1. Namely, first this assignment operator works, then second time this increment operator will work. Therefore, after the value of a, this a assigned to x, then increased a by 1. Therefore, the result of this process is equal to 1. This is the post increment. Okay, then let's see the pre-increment. We have the same variable x and A. We assigned 1 to A. And then we just implemented this pre-increment operator to A. This means is first we increased the value of A by 1, then assign the result to the X. Namely, after the value of A increased by 1, then assign it to X. Therefore, X equal to 2. This is the result. Namely, there are differences between post-increment and pre-increment. I repeat again, in the case of pre-increment, first we increase the value of A by 1, then assign it to the X. In the case of post-increment, first we assign the value to X, namely first we assign the value of A to X, then increment the A by 1. Therefore, the X is 1 and the A still 1. Okay, this is the difference. Okay, in the case of decrement operator, for example, post-decrement and pre-decrement, it's same. We are here just increase the value, and in the case of this decrement, we just decrease the value. That's the difference. Okay, now let's see an example. Actually, I prepared the code. Now I just paste it here. Okay, this is the example. First, let's say a simple example. We have a variable A. I just assign it to 10. First, I just print the original value. Then I will implement the post increment. Then print the increased value. In the second example, first I applied the decrement operator to A, then print the result here. Okay, let's see it. We have A here, its value is 10. Then I just applied the post increment. As the result, the value of A has been increased by 1. Therefore, 10, 11. Then, after that, after we get 11, and we just implement this post decrement operators. Therefore, by definition, this operation will decrease the value of A by 1. We just here 11, and now the value of A will be 10. Okay, let's print it C. Okay, the first we have original, then we have applied the post increment, therefore value of A increased by 1, 11, and then we just decrease it by 1 by using the post decrement, therefore the value is 10. Okay, now let's say another example. The difference between the post and the pre-increments. Okay, therefore first clear here and then also clear here, because now I have 10 here and I just add X and then X A. Okay, now let me print this one. This is the post increment example. Namely, we assign it A to X and then this A will be increased. Okay, let's see the result. Because we have this A value is 10 and then first we assign it the value to the X and then we are applying this post increment. Therefore, theoretically, the value of X is still 10. Okay, let's see it. Here we go. Okay, now let's see the opposite one, namely the pre-increment. Okay, now this should be 11. The value of X should be 11 based on the explanation previously. Okay, let me print it. Okay, 11. Namely, first we increment a by 1, then assign it to x. Therefore, the x value is finally 11. Okay, this is the increment and the decrement operators. Namely, in the case of increment and the decrement operators, for each we have two versions. The first one is post-increment, the second one is pre-increment. In the case of decrement, it's just same as the increment and the post-decrement and the pre-decrement. Okay, now let's see the decrement. Therefore, I just changed decrement here. Let's change it to minus minus. Now let's print it, and the result is 9, because first we applied the decrement operator to a, then the result has been assigned to x, because this gives us 9, and then that 9 has been assigned to x. Therefore, the result is 9 here. Okay, let's see the opposite one. For example, this is the pre-decrement. Now let's see the post-decrement. Okay, in this case, after the a assigned to x, then we are decreasing a by 1. Therefore, in this case, we are getting 10 here. For example, this is the 10. Okay, now let's do one thing. If I execute this code, I should get 10 and 9. In this case, because this is the post-decrement, therefore first the a will be assigned to x, then it will be decreased by 1. Therefore, we are going to get here 10, and in this line we are going to get 9. Okay, let's see that. Therefore, this is the 10 and this is 9. Namely, we just implemented the post-decrement. In the case of post-decrement or post-increment, first the value or variable will be assigned to x, and then that increment or decrement, namely the post-increment or decrement, will be applied. Okay. Now let's see the conditional or ternary operator. Okay, first we have condition, then we have if true value, then we have if false value. Namely, we have a condition here, and to check the condition, evaluate the condition value. If it is true, we use this value. If it's false, we use this value. First this condition, and then value if true, and then value if false. Okay, therefore first we check the condition. If true, we get this value. If false, we get this value. Let's see an example. Okay, now we have two variables, a and b. 10 assigned to a, 20 assigned to b. Now we are going to select the max one. Okay, in this case, as an example, we just use the ternary operator. We just saw that first we have condition. If this condition is true, we will take this value. If this condition is false, we will take this value. Okay, let's see it. Okay, this is the condition, for example. This is the condition. And if this condition is true, we will take this value. If this condition is false, we will take this value. Okay, let's see that. A is 10 and the B is 20. Here the condition is A larger than B. This is not true because this is false. Therefore, based on the definition, we will get B. This is the max value. Okay, let's see it. Here we go. The max value is 20. Okay, now let's say comma operators. Comma operator used to separate two or more expressions. For example, just like this. We have here two expressions. The first one is 5 assigned to b. The second one is b plus 1. Okay, therefore, among these two expressions, by using this comma, finally one will be selected. Namely, most right one will be selected. In this case, first we assigned 5, then we just added 1, and finally this result will be assigned to A. This is the comma operator. Okay, then let's see the Sizeof operator. In the case of Sizeof operator, this is very simple, and the Sizeof operator returns the size of a data type or variable. For example, if we have a data type, for example, just like this, or if we have a variable, int variable, and then we just use a Sizeof operator, and it will give us 4. Therefore, Sizeof operator can be used to check data type as well. We know that int is 4 bytes, float also 4 bytes, double is 8 bytes. Namely, double occupies 8 bytes of memory. Based on this Sizeof, we can know the data types. This is very important because when we use or when we automatically allocate memory at that time, this is very useful. We will use a lot of in the coming lectures. Okay, now let's see two examples. The first one for comma operator, the second one for Sizeof operator. Okay, we have assigned 10 to A, we have assigned 20 to B. Therefore, we are going to use this comma operator. First, we are using add and assign operator 5 because we have here 10, we are adding 5. We know this, we just learned that, and this value will be 15. Then we just using here b, we have the original value 20, and we know that this is the add and the assign operator. This value will be changed to 25. Now let's see another example for Sizeof operator. We have a variable a, and its data type is int, and its value is 10. Okay, now let's apply the Sizeof operator, namely Sizeof scope a. Therefore, this Sizeof a gives us 4. Then we have Sizeof float. For example, this is a variable. We are using the Sizeof for variable. In this case, we are using the Sizeof to data types directly. And this is also gives us 4 because float occupies 4 bytes of memory. If I just do here another thing, for example, here Sizeof double, then here double, this gives us 8. Now let's see it. In the case of a, it gives us 4. In the case of float, it will give us 4 as well. In the case of double, it will give us 8 because double data type occupies 8 bytes of memory. Therefore, we can use this Sizeof operator for variables just like a, and we also implement it or use it for data types directly just like this and this. Okay, now let's see typecast operator. typecast operator converts a variable from one type to another. For example, sometimes we use character, sometimes we might use integer, sometimes we might use floating point data types. But in practical applications, sometimes we need to change variable data types. At that time, we just use this typecast operator. Namely, we have a variable a, and its original data type is int, but we need to change it to float. At that time, we just use just like this. A, the previous original value a, and then we just typecast float. Now, as a result, this a will be changed to floating point data type. Later we will see example. Then we have point operators. Point operators, we have two kinds of point operators, the reference and the address. Actually, this is the pointer and this is the address of the pointer. Actually, last time we saw that the pointer is a variable and that variable storing the address of some variables. The pointer is very important concept in the C. Therefore, in the coming sections, we are going to learn pointer. But here, I just mentioned that we have pointer operators. But actually, what is it? We will learn it in detail in the later courses. Let's see the example for typecast operator. Now, we have two variables here. A, the value is 10. B, value is 3. But these two variables are int data type. Now, we are going to use typecasting operator to these two values. For example, we are going to divide A by B, and the result should be floating point. Okay, let's see it. Okay, 3.33. If I don't do this, okay, let's see the result. Now, the result is 3.33, but if I remove the typecasting, at that time, we see the result. It should be 3. Okay, it's just 3. If I use here, this should be give us 3.3, just like this. Namely, in the case of typecasting, it's related to the precision. Therefore, this is the example for typecasting. In the C programming, sometimes we need to use typecasting. At that time, we just use just like this. Until now, we have learned about a lot of operators. Finally, let's talk about precedence of some operators in C. Because until now, we have learned about a lot of operators. Arithmetic operators, relational operators, logical operators, bitwise operators, and assignment operators. We have learned about a lot of operators. But in the practical programming or in the practical codes, they have precedence. They have priority to execute. For example, we have here this code, for example, A plus B, then minus C. What is the precedence or what is the priority this one? In this case, the priority is from left to right. For example, first A plus B. The result, from this result, C will be subjected. In this case, we have A plus B multiplied by C. In this case, the priority is first, it calculated this. The result will be added to A. Therefore, this is the first priority, and the result and A, this is the second priority. Okay, in this case, we have here scope. Okay, in this case, A plus B scope 10 multiplied by C. In this case, the scope, the priority is most high. Therefore, first we calculate A plus B, then the result will be multiplied by C. In this case, for example, we have A equal B, B. Actually, this is just from right to left. First, we assigned 1 to C. Then, this result will be assigned to B. Finally, this result will be assigned to A. Therefore, in this case, the priority is from right to left. Just like this. 1, 2, 3. First, I repeat again. 1 will be assigned to C. The result will be assigned to B. Then the result will be assigned to A. In this case, we have here equal and assignment. This is equal. First, in the case of assignment and equal, the priority of equal is higher. Therefore, first it compares B and C. The comparison result will be assigned to A. Therefore, this is the first priority, and the result will be assigned to A. That is the second priority. Therefore, in the operators, there are priority or precedences level. If you're interested in, please see here. Okay, please stop the video and see this table. First column represents the precedence level. The second column represents the operators. Then this is associative. Namely, it's right to left or left to right. See the table in detail, and you can get some kind of message from this table related to the precedent level and the associativity of the operators in C. In summary, in this section, we have learned about a lot of operators, including arithmetic, relational, logical, bitwise, assignment operators, increment and decrement operators, and the conditional operators, and many other operators. Just display it as here, and with detailed examples. In the previous section, we have learned about data types. In this section, we have learned about operators in details. Therefore, our preparation is almost done. In the next lecture or next sections, we are going to learn coding. Therefore, in the coming sections, we are going to use these operators. Understanding these operators is fundamental to mastering C programming. Each operator serves a specific purpose, from performing arithmetic calculations to working with pointers and handling memory. As you gain more experience in C, you will frequently use these operators in a wide variety of programming scenarios, from simple calculations to more complex system-level programming tasks. Especially if we use the logical and the bitwise operators properly, we can speed up the execution speed of codes. This is very important. Thank you for your watching. Please subscribe.